we are going to discuss about digital control system, tutorial number 1, first chapter. And here is question: describe the data execution system and data distribution system with the help of block diagram. And to describe this distribution system, we have here digital controller. Okay, there is transducer and we have transducer. First of all, we give physical variable in data execution system. Physical variable is first of all converted into electrical form, and then it is given to, and it is done by transducer. And amplifier work here is to amplifies the input voltage signal, and low pass filter attenuates the high frequency signal like noise signal. And analog multiplexer is used for time distribution plus digital conversion. And if many of the analog signal has to be fed to the uh, fed to the uh, fit to the circuit, then we have to use multiplexer window and sample and hold circuit, hold the output signal from this multiplexer and given to AD conversion at sampling instant, and it is fed to the digital control system. And here is description what I tell. And we have then here then amplifier. What is the use of amplifier here? Okay, what is the use of amplifier? The amplifier amplifies the voltage output, one thing. Okay, voltage output of transducer, and it converts output signal into a voltage signal, and it buffers the signal. And the low pass filter, I already tell, noise signal reduction, and plus an analog multiplexer is used to give input. Okay, when there is many signal, and when the sample and hold circuit function is when switch is on. Okay, then finally it is converted into AD converter to digital one, and so on. Talking about distribution system, reverse of data execution system, we use here demultiplexer, and instead of AD conversion we use DA conversion, hold and actuator reverse, and we can do similarly. And moving to next question, we have explain the digital control system, mention the advantage of digital control system over analog. And this is the figure, same as before. We have data execution system that sample same. This is our data execution system, and we have, and this is a distribution system. And the main thing is the noise in this circuit is converted into digital form again by this feedback circuit. And we have here is one is feed forward circuit and feed forward circuit here. And we have another uh, feed forward circuit too. And and another important thing is here we have this clock. And this clock helps to give the specific timing. Okay, controller operation is controlled by a clock. And moving to next page, here is description what I talk about. At some point, okay, at some point varying amplitude either continuous or discrete and is depicted in figure, and the output is continuous time signal. Error signal is converted into digital form by the sample and hold circuit, and the analog digital converter and conversion is done at sampling time. And digital controller, this digital controller, okay, this digital computer means digital controller uh, process the sequence by means of algorithm and produces a new sequence, and its sampling time it its sampling time it produces a binary digit and must be converted into physical and so on, and digital to analog and old circuit control the sequence of number and numerical code into a piecewise control, and real-time clock is used to synchronize the events, and the output of the continuous signal is fed to the circuit directly through actuator. And the operation transform continuous time signal into discrete time, and it is sampling or discretization, and the reverse operation that transform discrete time data into continuous is data hold, and it amounts to reconstruction of a continuous time signal. We read later, and usually done by using one of extrapolation method. uh, and the sample hold, an AD converter convert continuous signal into a sequence of numerical, and such an conversion is called uh, coding and or encoding. And we have at every interval of time operate on such a numerical code and generate such a thing. And the advantage is digital over analog is one is intelligent motion, another is optimization of fuel economy in automobile, and refinement in the operation of household appliances, and decision making capability and flexibility. And we have to another question is comparing different sampling signal. And first of all, sampling means process of converting an analog signal into digital one is sampling process, and comparison among those operation is used for the sampling of continuous time signal. And what is period? There are four types of sampling, that is periodic sampling, multiple order sampling, multiple rate sampling, and random sampling. Mm, Periodic sampling means sampling if sampling is done with periodic or equally spaced time, that is tk is equal to kt, and multiple order sampling mean pattern of tk is repeated periodically, that is tk plus 1 minus tk is constant, and for all k. And multiple rate in this multiple loop, and the larger time constant involved in one loop, larger time constant involved in one loop may be quite different from that other loop, and may be advisable to sample slowly in loop. Okay, we have to it is advisable to sample slowly in a loop having a large time constant, and sampling rate must be fast in those of smaller time constant. And digital control system have different sample period in different feedback period, and random sampling in this instant sampling instant are random, and tk is a random variable here. And another question is what is mean by quantization, and quantization error. Explain it with corresponding waveform. First of all, we move to quantization error. Okay, quantization. The standard number system used for processing is the binary number, and it can be either on or off. And an on pulses creates this to an amplitude level, and the quantization level is difference between adjacent decision point. and Q is equal to full scale range upon 2SN, and FSR is a full scale range, and left LSB leftmost bit is the most significant bit, and while the rightmost bit is the least significant bit, and LSB is the quantization level. Level Q and quantization error, and due to quantization error, due to the fact the formula is result in a finite resolution, and the analog signal must be rounded up, and we have this, okay, and it is here what only a finite number of level which can be integral multiple of uh, dash dash dash, and quantizing process is approximating process, and analog quantity is approximated by the finite digital number, and quantization error is rounded up here. Clearly define the quantization level, and we have this is also quantization and so on, and we do this, okay. One is output, okay, like analog input and output. We have error difference, okay, and this is a error, and tracking mode, old mode, that one charge on capacitor in the circuit tracks circuit, and that circuit when off also over a constant period of time, and which is old circuit, and practically selecting a track mode is not instantaneous before reacting to the tracking mode. And lastly is describe objective of why we do sampler is over a piecewise signal and AD converter, and here is a figure, okay, which can be easily understood, and it's in op-amp. One is input buffer amplifier, and impedance output is the output buffer amplifier, and which buffer the voltage on the output volt capacitor, and when the switch is closed the capacitor charges up to a average level of the input signal. That means the charge on the capacitor in the circuit tracks the input voltage, and this mode of operation is known as tracking mode. Now when the switch is open, okay, and the time taken for switching from tracking mode to mode is aperture time, and we can reduce this uh, this uses and switches open, and we can use state leakage, and the capacitor voltage holds constant for a specific time known as, and so on, and compare among different continuous time analog signal and continuous time quantized signal mean discrete signal, and sample data signal discrete interval of time, and digital signal, and lastly reconstruction of signal mean this is our input signal, and if we reconstruct a signal using a whole circuit, zero whole circuit, this will be result. First order for this will be result. And thank you, this much for today. Subscribe my channel. Thank you.